enthusiasts are joining us from Radisys Corporation. First up, we have with us Mr. Sunil Kumar Verma, who is serving as the Director Engineering at Radisys. He also presides over a committee at Radisys to adopt DevOps and CloudOps practices at Radisys. Sunil is joined in today's session by his colleague Mr. Pranay Mishra, who works at Radisys as Director Quality Excellence. Pranay mainly focuses on supporting agile transformations and works closely with the engineering team for DevOps and Cloud Ops practices. Today, this powerful duo are going to share some very interesting facts on the SaaS hosting journey on cloud and DevSecOps pipeline creation for SaaS hosted solution. So let's all welcome Mr. Sunil Kumar Verma and Mr. Pranay Mishra.
Today we are going to talk about SaaS hosting on cloud using CloudOps and DevSecOps. I am Pranay Mishra. I am part of Radisys as Director Quality, and I have got my friend and colleague Sunil, who is Director Engineering. We'll be walking you through this journey.
Hi, everybody. This is Sunil. I've been practicing the cloud hosting and the DevSecOps practices at Radisys for last close to 20 years now. So yeah, we're excited to share our journey. So I'll hand over to Pranay to walk through the initial set of slides.
Sure. Thanks, Sunil. Next slide, please. All right. So friends, agenda is I'll give you a quick glimpse at where we started from and a little bit of our journey. What is the background, and then we'll move to our CloudOps journey in detail. What is the method? How did we go about planning it? What are the tool chains? What is the workflow that we have used? And at the end, we'll summarize it. And then if time permits, we can have even some discussion. Okay. Shall we move to next, please? Okay, so I think Radisys started like any other company. We used to follow CMI and ISO, but somewhere in 2017-18, we decided we'll do Agile. And if we have to do Agile, very soon we realized that we have to focus on DevOps. And probably in 2019 onward, we started heavily investing in DevOps. And as part of that, DevSecOps and CloudOps became, integral part of 2021. Our focus area was CloudOps. Because what is happening, just to give a little bit of background, we are in telecom space, and telecom space, especially in network related products, till couple of generations back, till 3G, software defined networks were like a novelty thing or not that much prevalent. But with advent of 5G, that is what is the general thing is, and most of the software products that are there in network are slowly shifting towards cloud, and hence CloudOps. So that is the background. What was the motivation? Now we'll talk about how did we go about doing it. So Sunil, next. All right. So I think the way we started our CloudOps journey, it's kind of commonsensical. First thing we need to figure out, we have got a set of products, multiple products in different domains in telecom. So we had to figure out what all kind of models, hosting models we have to think about it, whether it will be self-hosted, partner-hosted, customer-hosted. Sometime we have to have products which have to coexist in virtualized cloud world as well as on bare metal, because that was the demand of customer. And we have to support all that together. So that was the first assessment, followed by what we did. So if you are a normal, say, typical cloud ops or apps development company, you would have a structure. But the second part of this for our journey was to look at the organization structure. And given we are in telecom infra, we had to figure out, do we have the right set of people and team, and the organizational structure to support this journey. So we looked at our cloud engineering, DevSecOps teams, CloudOps, and do we need SRE? We invested in the right set of people. Once we had right set of people, then the obvious thing is to go to the next step, where we had to assess what are the existing tools and techniques, etc., that we are using, that is available in our tool chain, that is available in our pipeline, and where are the gaps. So these experts helped us to assess those gaps, and then followed by implementation, where we had to re-architect, redesign certain portion of our CI/CD infra, certain portion of our products also to meet the need of cloud. And then we went about, implementing it, and thereon monitoring and optimizing it. So that is at very high level the way we have gone, and I think anybody will go through this journey. Now, the unique thing is we are coming not from the normal cloud ops scenario. We are coming from a product company where we build product for networks, telecom networks. So basically, we build network element that are deployed in telecom, and traditionally they never used to be cloud centric. So that is where we have to figure out how to move everything towards that. So the idea was, if we try to move it, and if we ask all the product line, hey, you try to do your own, people will be lost because it's a large organization. So we had to give some kind of model or a staged approach so that everybody can look at this, figure out where their product or product line stands and how to move forward. So in this journey, last couple of years, we kind of shaped up this model. We call it FAST model for SaaS hosting. We start with foundation, and we built upon that. We add few things. We reach a stage where we can host a product, existing product, sometimes legacy product, to a cloud in certain way. Then from there we shape up and take it to a level where we can onboard customer and we can support a large customer base. So that is what we call takeoff. So this is the model that we have been using, and the reason we wanted to share is because I thought probably for kind of scenario we are dealing with, a lot of companies are in this, and this kind of approach can be handy. So to take you in more detail, I would hand it over to Sunil. Sunil, over to you.
Thanks, Pranay. So, hi everybody. So, the FAST is a model that we kind of coined it as a name. However, as Pranay mentioned, this is for a SaaS hosting where you're doing a self-hosting. So, I mean, as in the previous slide, Pranay did mention that no, there could be multi-type of hosting where you're talking about self-hosting, you're talking about partner hosting, when you're talking about customer hosting, and depending upon what kind of use case you are on, like B2B, B2C, both B2B, B2C. So depending upon the use case, you would define your hosting requirements. But this whole model is predominantly focused towards self-hosting. And in that case, we came up with this FAST model. And the first step here is the foundation. So, I mean, there's a good amount of write-up here, but I will probably try to give a gist of it. So at a foundation level, what we are trying, like, there's an engineering team who kind of feels that no, they have a business case to have their products on cloud. Especially in telecom world, it has always been a challenge in the very beginning world that no, will we be successful in cloud, considering the customers having a lot of focus towards having infrastructure on-prem, which is in their own data center. So defining a use case is a very important thing, which is a business use case. And from that business use case, identifying an MVP scope, what can be implemented so that we can be sure about what we intend to do from the business case is actually achieved, and people kind of do a POC on it and be confident about, yes, this is the path we can go. So defining a business use case, defining an MVP scope from a product perspective, and then working towards getting it implemented on cloud. So effectively what we are trying to do, so you define a scope, you find a cloud service provider. There are various cloud service provider today. So we need to stick to one. At this stage, we are kind of doing a proof of concept of the MVP. So we define a cloud platform to be used. Then we limit to clouds. When we go to cloud services, our focus is not about going too deep into cloud services, but our focus is more about how can I bring my product on cloud? So it's all about integrating my product onto cloud services. So that's a core focus. And once so whole of the foundation level is focuses on creating the knowledge set. So kind of creating a very good understanding of how a product can be integrated on cloud. What are the challenges? What are the technology aspects? What are the open source components you need to use? What are the product redesigning aspects that needs to be done? So quote unquote, you are kind of creating a business use case. So if you look at the outcomes, what we're talking about, you're kind of trying to align with the business use case. You are kind of having a product refactoring requirement, and then you're having a very good understanding of how to do it in terms of the open source components as well as the product components. So once you pass the stage, effectively, you are now ready to get the product MVP implemented. So from a product engineering perspective, now you know what are the engineering requirements. So you kind of set up a cloud engineering function at the engineering level. Then at the same time, considering that you need to do a hosting, you need a cloud ops function to be created in the organization. And then you need, what you're effectively doing is, if you kind of relate to the slide that Pranay presented before, the reorganization. So we're talking about setting up the organization to be able to have a product hosted on cloud, which means you have a cloud engineering function set up, which are going to focus on product engineering, which will be taking care of product integration to cloud services. You are setting up a cloud ops function, which is mainly focused on setting up the cloud infrastructure to be able to integrate your product or to be able to bring up your product on cloud. So those are the two functions that kinds of start setting it up here at a part of reorganization. In terms of product, we are actually going to implement the MVP scope here. So we did a POC in the foundation level to figure out the technology know-how. At the augmentation level, we are actually focusing on implementation of an MVP. So product MVP gets done here. You are, while you're setting up the operations functions, the operation function is going to focus on doing their level of POCs to define their requirements in terms of to be able to execute the operational requirements would be more about setting up the cloud infrastructure, the scalability, the security, the entire tool chain that would be required to deploy this whole solution on cloud. So all those aspects will come there. At the same time, if traditionally most of the organizations have their own DevOps function or DevSecOps function. Now these functions needs to augment their capabilities to be able to host the product on cloud, which means the DevSecOps functions, which were originally focused on product engineering, are also now going to focus on having the CD, the continuous delivery on cloud. So there are a set of requirements that cloud DevSecOps functions are going to derive from at this stage and be ready to be able to deploy the product on cloud at in a defined interval. So at the end of augmentation level, what we are trying to achieve, we achieve. So if you want to say where I am, I mean at what level I am, if I have to say I am at augmentation level, I would have a dev cloud engineering function set up in my organization. I would have a cloud ops function established in my organization. I would have identified the tool chains from cloud ops and DevSecOps perspective that would help me set up the flow. I would have got a product at an MVP level, kind deployed on a cloud platform more manually. And when I say manually, it is like the operations are still kind of getting ready to be able to create a cloud infrastructure on a click of a button. But the product has come to a stage where it can be deployed manually on cloud. So the objective here is that you can start doing trials, you can start doing demos, you would like to get a feedback in terms of the business case that you have created and the foundation level, and is it actually reaping benefits in terms of customer acceptance, in terms of the uptake that you are looking for your solution in cloud. So this is a phase where your sales function, your PLM function are effectively going to start talking about your product, which is going to be in cloud. They're going to start doing demos. They're going to get a sense of customer in terms of whether we're going in the right direction or not. So once we are kind of done at this phase, your cloud ops function, your DevSecOps function have identified the low level requirements that they need to do to automate the entire workflows. And from a product perspective, you've got a good feedback from the market in terms of how well your product is placed, what are the areas or gaps on the product that needs to be implemented to enhance the product from MVP to a real customer adoption level. And that's once you step up from the stage, you are actually coming to shape up. So all the feedbacks that you've got in terms of product, you're going to focus on in shape up. So the product engineering is going to focus on the fixing, or probably I would say augmenting the MVP to a level where you can actually have customer onboarded. So all the feedback gets implemented there. Now, because you're hosting it on cloud, and there are now at this stage, you are looking at customer to be onboarded, you have to define business KPIs. You have to define KPIs both in terms of SaaS hosting, in terms of business uptime, the upgrade, and support. So once these KPIs are in place, to make these KPIs, to make sure that these KPIs are being met, SRE functions comes into picture. So we need to now define this SRE functions in the organization, which is going to focus on business uptimes, the KPIs for product and the SaaS hosted solution. So that's where you focus on SRE roles, all the work that DevOps and CloudOps, which you would have done in the augmentation phase more manually, they work towards automating the entire workflows so that you will be able to create the cloud infrastructure on a click of a button. You'll be able to deploy your product on a click of a button, and you'll be able to monitor the statistics from the platform as and when it is getting generated. And at this stage, you are also focusing on ensuring that your scalability, your product is scalable, you have high availability implemented, your product has all security checks and balances on play, so that when a customer is onboarded, there is no security breach that can take in place. Also, at a shape up level, you have started monitoring your cost, because when you step into cloud hosting, initially you may not be so much focused on cost. Your focus is predominantly on getting the services on cloud. But at this stage, you would start monitoring your cloud service utilization, your overall cost, your business KPIs, and start making sense of what is right and wrong. And when I say what is right and wrong, is it right in terms of the amount of sales that you're doing? Is it kind of aligning with the cost of the product that you're providing to customer versus the overall operational cost? And those details are gonna be fed into the takeoff stage to optimize. So takeoff stage is all about optimization. This is where you're going to take all the KPIs, work towards automating the SRE functions. The SRE function members, engineers, support people, they're going to work more towards ensuring that the business workflows are automated so that their day-to-day operations are very much streamlined. And there is a defined workflow that they're going to execute on. There's a standardized DevOps and CloudOps pipeline that is available to be able to host your solution on a cloud platform of choice. You are constantly monitoring the platform, you are having reports, you are on a periodic basis be able to review the business in terms of how the customers are coming into the platform, what are their feedbacks, how the support tickets are trending, and how you can work or augment your product to be able to support those customers or be make the customer experience better. So that's the takeoff stage. So, I mean, at the takeoff stage, what we are talking about outcome, you have a fully functional SaaS hosted solution. You have very much optimized DevOps and CloudOps pipeline. You have an optimized SRE function, which is kind of supporting the entire hosting on cloud. You have onboarded customers. You have engaged with them with the growing customer base. And there's a continuous improvement workflow that has been in place based on metrics and performance. So that's the kind of a fast model that we had come up with, and it has worked for us a couple of product lines. So that's this slide, and probably I'll switch to the next. Now, coming to the tool chains. Now, once you start hosting, I think so the point that comes into mind is what are the tool chains that we intend to use? So the tool chains that have been, of I would say something that worked for us very well is we have been using as a DevOps or DevSecOps or a CloudOps engine, which is the base underlying engine. We've been using Jenkins and GitLab. When it comes to deploying our solutions on cloud, we have two kind of solutions. One is either via Terraform, where we have created our own automation framework, which kinds of take the configuration and deploy solutions on cloud. And second is tools. It's an open source tools as well as a paid tool. It's Cloudify. It's a good solution. It's a cloud platform agnostic. It can work for even on-prem clouds. It can even work for public clouds. So that's where we kind of adopted these two tools in our pipeline. Once you have got the cloud infra set up, you would like to deploy your solution. So as part of the application deployment, we have been using Helm, we have been using Puppet, we have been using Python. So these are the three, probably I would say, tools and scripting languages that we have used to deploy our solutions in cloud. Next, in terms of the image store, where we're going to store our container images, Docker images. So we have been using Nexus, ECR, Azure container registry for different cloud platforms. Like for AWS, it was ECR. For Azure, it was ECR. And for on-prem, we have been using Nexus repositories. Now, once the whole thing is set up, your product is deployed. Now, you want to monitor. You want to monitor your cloud platform. You want to see how things are working there. Your infrastructure is up. If there's any fault, if there's a fault handling needs to come into picture. So the monitoring services are, we have been using CloudWatch, we've been using Zabbix. Zabbix is an augmentation where it's kind of a tool that we are using for both cloud and on-prem monitoring. PagerDuty has been a tool that we are right now evaluating to integrate for our SRE functions. So that's pretty much around monitoring. These are the tool sets that we use. And towards the end, on the security, so we have been using as well as a tool to help to take care of intrusion prevention and detection purposes, and then OS6 in terms of the open source security scans. So that's on the tool chain at a very high level. Now, this is not a complete tool chain. I'm sure the DevOps pipeline has many more tool sets into it, but these are the core tool chains that we have focused on in, while we focus towards hosting on cloud. This is a very high level view of our architecture diagram. So here, if you see, we are kind of, as we discussed in the beginning, we have been from a telecom space, and telecom space we have are probably the late adapters. I would say the late adapters to the cloud platform. So a good amount of their DevOps, DevSecOps functions have been on-prem historically, because that's a journey that was started in 2018, 2019. So if you see an on-prem data center, that's where most of our DevOps functions are set up. Effectively, all your microservices, all your product packages gets done here. And once we are ready, from our data center, we trigger the infrastructure creation as an automation using Terraform and Cloudify. The entire cloud infrastructure gets created. I mean, this is a sample of an AWS cloud. Similar to that, you can have GCP, you can have Azure, you can have any other platform implemented in the same way, where you have your on-prem data center, where your tools like Terraform, Python, CloudFormation, Puppets are being launched. And these tools end up creating your cloud infrastructure. Once you set up the entire cloud infrastructure, the approach that we have taken is we split this infrastructure into two parts: a set of workloads that are for DevOps, DevSecOps operations, and there are a set of workloads which are for SaaS nodes, this is where your application software or your telecom software sits. So the approach that we've taken is we set up the infrastructure from our data center. Once we have set it up, we kind of take all our DevOps, DevSecOps, and tools in terms of automation. We kind of take all the scripts from our local data center big buckets, we push them out onto our Launchpad nodes, DevOps tools nodes, and then from here, we deploy the entire SaaS solution. So effectively, the hosting is actually triggered based on these DevSecOps nodes. These nodes focus on three things. First, they deploy the solution. Second, they monitor entire services are up or not. Third, they validate the product. And then towards the end, they make it up and live for product customers to use. So that's kind of a high level framework. If you see, we have kind of done a segregation of the VPCs here, so that the DevSecOps node securities doesn't impact your SaaS node securities. We have a proper security groups in place to be able to make sure that there's not much of security, there's not much of an access between the DevOps node to the actual SaaS nodes without being, I mean, these are all very well controlled in terms of security groups that have been set up. And for those SaaS nodes, if you want to go to the public in terms of web hosting, you take Route 53 as a service from AWS. And in case of you're going to have a dedicated network channel, dedicated traffic channel you want to use, you use AWS Direct Connect services. I mean, similar to that, there are services on Azure, which focuses on, you can say Azure Express Route is a similar service that you can use on the web. They have their own DNS services, so you can use that. And yeah, so pretty much if you look at this diagram, there's a data center which kind of creates everything. Then you come on, copy all your images from Bitbucket, which is version control, put into the DevOps node, and then deploy the entire solution. So that's a very high level architecture diagram of our cloud hosted solution. I'll step into the next stage. I mean, here we're talking about our CI/CD pipelines. So we have kind of set up a 5-layer DevOps pipeline. So level one, we call it level 1 to level 5. So level 1 CI mainly focuses on standard DevOps practices, which are focused on static analysis, unit testing, code coverage, code complexities. This is where we kind of do an open source scan in terms of at a microservice level. And once it qualifies this level, and this is kind of triggered per commit. So as and when every developer commits his code, all these checks gets into place. Once they get passed, they step into level 2, which is where we build our microservices. This is where the container images gets created, they get scanned. This is done a couple of times a day. In our case, it's 4 times a day. We try to do a microservice level scan as well as sanity. If I have a solution deployed on cloud, and if I have a fix to be deployed as a microservice, if it passed level 2 CI, I have a pipeline to push it into the cloud as a microservice patch. So this is the stage where I can upgrade my solution at a microservice level. However, if you look at the agile practices, We have this concepts of sprints, we have this concept of cadences. So if you follow the agile practices, you will step into the next stage of cadences to your own internal validation team. That's where the level 3 CI comes. This is kind of a gate being set up by validation team to qualify for the product cadence. So at this stage, we kind of regress our product at a solution level and ensure all new functionalities are stable. And this is run at every cadence. Though it is created every night, it is run every night, but at a cadence level, this has to be passed to enable the services for our system validation team to perform tests. And level 4 CI is predominantly focused on regression. So as Pranay mentioned, our product line is actually a 30-year-old. We are a 30-year-old organization. So we have products which has a lot of legacy features. So we would need to regress them every time we enable to our customers. So we have a level 4 CI predominantly focuses on regression. So at this stage, once you look at level 1, level 2, level 3, level 4, once we pass all the stage, we are actually ready for any customer deployment, which is on their own data center. So all this is for on-prem deployment, and this is for on-prem data center. Once we qualify here, we are good for on-prem deployment for our solution. But if you have to step into cloud, now this is where we get into sandbox environment. This is where we talk about level 5 CI. This CI focuses on cloud packages creation, cloud infrastructure creation. So this is where we talk about, if you look at our fast model, we talked about automated CloudOps and DevSecOps pipeline. So this is where once a product passes level 4 CI, we trigger level 5 CI. And at this stage, what we intend to do, we are spinning up a sandbox environment. This is kind of a 30 to 40% of our overall production capacity. We spin up the environment exactly same as production. We deploy the entire solution, the SaaS solution, onto that sandbox environment. We run through Cloud Sanity. Now, when we talk about Cloud Sanity, what we're talking about, if you connect back to what I spoke earlier, for a product engineering to connect to cloud, they need to do certain engineering modifications for augmenting or integrating with the cloud services. So that aspects of a product needs to be rigorous, whether these integrations are in place, your product is up and working. So there's going to be a very basic product sanity. I would say platform regression happens here. Once we kind of qualify at this stage, including cloud security scan, is where we are ready for production. Now, product may go through multi times, I would say probably in a program increment. If you connect with a program increment is where you kind of create a product phase and you kind of develop it. So in a program increment, I might be ready to level 5 stage, maybe 5 to 6 times in a quarter. And at that stage, we can do that upgrade onto cloud at a click of a button. And that's something that CloudOps and DevSecOps team review the reports at level 5 CI and make that decision. And once that report is being affirmed and accepted, we kind of push the upgrade to production. So it's a single click upgrade to production. We follow blue-green deployment strategy here, where you have an active site running as blue and a new release coming in as green. Once the green site has been certified, then we shut down blue and let the whole traffic happen on green. So, I mean, this is a standard strategy for any cloud hosting, or probably I would say to have zero downtime upgrades on cloud. Yeah, but for at a microservice level, we follow canary and a rolling upgrade strategy. That's something that we can trigger at a level 2 CI, as I mentioned earlier. So if you see, our DevOps pipeline is kind of split into on-prem and AWS. So it's kind of a hybrid model that we operate on here. That's all I have here. And then I'll move to the statistics and results. So in terms of coverages, this whole framework that we have created, we have kind of impacted 14 projects in our organization. There are 60 plus DevSecOps and CloudOps pipeline implemented to cater to various needs in terms of CloudOps and DevSecOps functions. We have two cloud platforms where we are kind of hosting our solution. This is AWS and Azure. And we have 4 private cloud platforms supported, which is coming from customer-defined cloud platforms. And we were able to augment the same pipeline to be able to deploy solutions on customer clouds, even in case of private clouds. In terms of results, we have 14 simultaneous release active on a public and private cloud. So we kind of push these release on the go simultaneously from our click of a button framework from sandbox to production. We have got a 30% efficiency gain from where we started. And I think so this efficiency gain is going to be looked forward to as we are in the If you see the fast model, we are at the takeoff level. This is where we are kind of focus on more optimization and efficiency. So we have got yet 30% of efficiency at this stage. We are looking for the graph to go up. We have two active SaaS hosted platform where we have customer onboarding, and there are more products are in transition. And we have a very good customer experience based on the initial trials and POCs that customer did on our platform. Very good feedback, and we look up to enhance it as we move forward. So that kinds of covers what I intend to say. At a nutshell, we intend to say that there is a model that we can apply through which we can evaluate at what stage we are. It allows engineering, CloudOps, and SaaS function, SRE function, to grow at different levels to define their requirements and get an automation in place. So towards the end, you would have a successful pipeline that can host your solution on cloud with security, scalability, and operations working very well defined matrices. That's all I have. I'll open for any question and answers here.